My name is Nurul Emelda Nasrin binti Azmi. My metric number is CE250045. I want to present about the introduction. So the background of introduction is first, EV fast charging system are widely used in smart grid infrastructure. And second, shunt voltage is an important parameter for monitoring power flow. Third, about missing telemetry data may occur due to logging delays. And fourth, about numerical interpolation method can estimate missing value accurately. And then about the study focus. First, about the estimate the missing shunt voltage at t equals to 1.30 second. Apply for large interpolation method and Newton's divided difference method. Next, I want to present about problem statement of the project. Number 1, voltage data at t equals to 1.30 seconds was missing due to telemetry logging delay. And second, missing data can affect system monitoring and analysis. Number 2 is about objective of the project. Number 1 is about estimate the missing value using Lagrange interpolations. Number 2, estimate the missing voltage using Newton's divided difference. And number 3 is about compare both method. And fourth is about verify result using MATLAB.
Hello, my name is Muhammad Khalis bin Azam Faisal. My matrix number is DE240128, and I will be presenting methodology and data as well as manual calculation for our problem. So this is our problem. At a smart grid electric vehicle fast charging station, the shunt voltage profile across a bidirectional power converter is digitally monitored at specific cycle time intervals. Due to a temporary telemetry logging delay, the voltage value at a critical transition point was missed. The recorded data points during the pre-discharge phase are as follows. So we are given a table with two rows. The first row is for cycle time, which is in seconds, and the bottom row is for shunt voltage, which is in voltage. We are given 5 data entries each. So the task is we need to estimate the exact shunt voltage value at the critical time of 1.3 seconds. We have to calculate the estimated voltage using A, the Lagrange interpolation method with a quadratic or second order approximation using the last 3 data points, which are 1.25, 1.4, and 1.85 seconds. And B, using the Newton's divided difference method. I will now present the manual calculation for our problem. So for the first method, which is the Lagrange interpolation method, by quadratic approximation, we need to identify the data points to be used for this method. In this case, the task requires us to use the last 3 data points, which is 1.25, 1.4, and 1.85 seconds. After that, we take the values from the 3 data points from the table and insert them into the Lagrange interpolation quadratic approximation formula. From there, we calculate and obtain 1.1804 volts. Next, for the second method, which is Newton's divided difference, we need to make a new table based on total data points of the given table. Then take all of the data from the given table and insert them into the new table. For this task, we got a 5 by 6 table. The values for the first and second column, which are Ix and Vi naught, are taken directly from the given table. Then, for the third until the final column, we have to calculate it using the formulas for Vi1, Vi2, Vi3, and Vi4. After we have filled in the table, we take the values and insert them into the formula for Px. From there, we calculate and obtain 1.1660 volts. So the final calculated values obtained from the two methods show a difference of 0.0144.
Next, my name is Nur Najwa binti Saari. My metric number is CE250012. For this project, we use MATLAB to estimate the shunt voltage at a target time of 1.30 seconds using two interpolation methods, which are Lagrange interpolation and Newton divide difference. For the first common, clear CLC and close, all we are used to clear the workspace, common window and close any previously opened graph. This ensures that the time simulation starts in a clean environment. Next, the given cycle time and shunt voltage data were entered into MATLAB. The target time was set to 1.30 seconds because this is the value that we wanted to estimate. For method A, we use Lagrange interpolation. In this section, three data points closest to the target time you are select. MATLAB then calculate the Lagrange coefficients, namely L0, L1, and L2, which we are used to construct the interpolation polynomial. After that, the estimated shunt voltage at 1.30 seconds was calculated using the Lagrange formula. For method B, we use Newton divide difference. First, a divide difference table was created using all five data points. A next for loop was used to calculate the divide difference for each level. The values obtained from the table were then used to construct the Newton interpolation polynomial. Next, the Newton polynomial was evaluated at the target time of 1.30 seconds to obtain the estimate shunt voltage. After complete both interpolation method, the divide difference table was displayed in the MATLAB common window to show the calculate coefficient and intermediate result. For the graphical visualization, MATLAB generates additional points using the linspace function to create a smoother curve. The Newton polynomial was then evaluated at this point to produce a continuous interpolation curve. Finally, the graph was plotted. The original telemetry data were displayed as blue points, the Newton interpolation curve was displayed as a red line, and the estimate value from both interpolation methods were marked on the graph for comparison. This coding should to allow us to compare the performance of Lagrange interpolation and Newton divide difference in estimating the shunt voltage at the select target time. Next, I will discuss the result obtained from both interpolation methods. For the Lagrange interpolation method, the estimate shunt voltage at 1.30 seconds was 1.1804 volts. For the Newton divide difference method, the estimate shunt voltage at the same time was 1.160 volt. When comparing both methods, the difference between the estimate value was only 0.0144 volt, which is very small. This shows that both interpolation methods provide consistent and reliable results for estimating the missing voltage value. Based on the graph, the interpolation curve follows the trend of the original data points, indicating that the estimation is reasonable and accurate. Therefore, both methods are suitable for estimating shunt voltage in an EV fast charging station. This slide shows the result for the MATLAB coding. Based on the graph, the interpolation curve followed the trend of the original data very closely. The estimate value from both methods are also very similar, which show that the results are reliable and consistent. We can see that the shunt voltage increases as the cycle time increases. Therefore, both interpolation methods are suitable for estimating the missing voltage value.
For discussion, the missing telemetry data can reduce monitoring accuracy and affect system performance. Therefore, interpolation techniques are useful for estimating unavailable measurement. The Lagrange quadratic method uses only nearby data point, making it simple and efficient for local approximation. However, It does not consider the overall behavior of the dataset. In contrast, this neuter divided difference method use all available data point and provide a better representation of the overall system trend. It is also more flexible when the additional data point are added. The estimate value option were 1.1804 volt for light range and 1.1660 volt for Newton method. Since the difference is very small, both method can be considered reliable. Furthermore, the MATLAB result match the manual calculation, confirming the validity of the numerical method.
Assalamualaikum. My name is Muhammad Faik. Today I will discuss about the conclusion. For conclusion, the missing shunt voltage at 1.3 second was successfully estimated using two interpolation methods. The light range interpolation method produced a voltage value of 1.1804 volt, while Newton divided difference method produced 1.1660 volt. Both methods show strong agreement and provide a reliable estimate. However, Newton method is slightly more robust because it uses all available data points in the calculation. Overall, these studies demonstrate that numerical interpolation is an effective tool for estimating missing telemetry data and can support accurate analysis in EV fast charging system.